Hello, I am Susobhan. Today I am going to discuss the instruction cycle in 8085 microprocessor. So before discussing the instruction cycle, we have to know what is instructions. Okay. So instruction is nothing but it is a command given to the computer to perform several kind of tasks. Okay. So to perform a particular task, a programmer writes a sequence of instructions called program, and program are basically stored into the memory. So after that the CPU fetches one instruction from the memory at a particular time and execute it. So the necessary steps that a CPU basically carried out to fetch an instruction from the memory and to execute it constitute a cycle, and this particular cycle is known as instruction cycle. Okay, so instruction cycle basically constitute phase cycle and execution cycle. So IC is equal to FC plus EC. So FC known as the phase cycle and EC is known as the execution cycle. So during the fetch operation, PC or the program counter basically holds the address where the output is available. Then it will be transferred to the memory, and memory, after that memory place the opcode on the data bus, then it will be transferred to the CPU. So during the execution operations, so opcode will fetching from the memory, and after that it will be goes to the data register, then to the instruction register, and after sending to the instruction registers it is needed to decode. Okay, that is why it will be fed to the decoder circuitry, and after that the executions begins. So this is the timing diagram of an instruction cycle uh, in Intel 8085 microprocessor. So here you can see there are several kind of T states are required to complete a machine cycle. So if we carefully observe this particular flow diagram, we can conclude that there are two kind of machine cycles are given. One is machine cycle 1, another one is machine cycle 2. So machine cycle 1 constitute 4 number of T state, T1, T2, T3 and T4, and similarly machine cycle 2 constitute 3 number T state, T5, T6 and T7. So it is noted that from this particular flow diagram we can say that for fetching and particular instructions, how many T states are required? It may be 4 or sometimes it may be 3. Either 3 or 4 number of T states are basically required for fetching and particular instructions, and for execution purpose 3 T states are required, and here in this diagram it is T5, T6 and T7. So this entire cycle is called the instruction cycle. So we can say IC is nothing but that this is the constitutions of phase cycle and execution cycle. And the second diagram, we can see the typical phase cycle in a microprocessor. So there are 3 number of T states are required for fetching, T1, T2 and T3. So in first T state, T1 T states or the first cycle, the address of memory, the address basically sent to the memory. Then in second cycle, reading the opcode. It is necessary to read the opcode, which kind of tasks could be performed. Okay, it is necessary to read the opcode from the memory. Then it will be transferred to microprocessor via data bus, and this is happening in third cycle or T3 state. Okay, so now in next slide I am discussing the machine cycle and the T states. So the necessary steps carried out to perform the operation of accessing either memory or input output device constitute a machine cycle. So I have discussed already in previous slide. In other words, necessary steps carried out to perform a fetch, a read or a write operation basically constitute a cycle which is known as the machine cycle. Okay. So in a machine cycle, one basic operation such as opcode fetching, memory read, memory write, input output read write is performed. So an instruction cycle consists of several machine cycles. The output of an instructions is fetched in the first machine cycle of an instruction cycle. So most of the single byte instructions, for example, MOV instructions, ADD instructions, requires only one machine cycles to fetch opcode and execute the instructions. But for 2 byte or 3 byte and 3 byte instructions require more than one machine cycles. For example, ADD address, STA address. Okay, for this such kind of instructions, there are several kind of instructions are there. So for this kind of instructions, there are more than one machine cycles could be needed. Okay, so all of this has been shown into this flow diagram. Now in next slide I have discussed the instructions and data flow. So if we carefully observe this particular figure, we can see that the opcode first comes into the memory data registers, which is denoted here by NDR, or simply it is called the data register as shown in this figure. In case of Intel 8085 processor, there is a data buffer for this particular purpose, and the operations code is then placed in the instruction register, which is called IR. The instructions then decoded by the instruction decoder, then it will be placed into the program counter, which is called ECE. And finally, the program counter, the content of the program counter is incremented, and after that it will be transferred to the MAR, which is called the memory address registers, and finally it will be placed into the memory address bus. So this is the entire flow diagram for instructions and data flow in Intel 8085 microprocessor.